start the second flight. Okay, so the opponent will challenge the reporter for just one point in 1 minute.
Okay, we are going to charge that ping-pong rocket.
Which number?
5.
Number 5. Ping pong rocket. Accept it. Accept, yeah. So the duration of it from the reporter. 10 minutes. Yeah. The name of
ping pong ball is placed in a container of water. When the container is dropped, the ping pong ball will get launched to a great height. While maximum height can be reached is up to 2 meters of water. And our main goal is to explain the phenomenon and investigate the relevant parameters affecting the launch height. Here's the phenomenon explanation. To explain the phenomenon efficiency, we divide the phenomenon into 2 parts: before collision and collision. Here's the slow motion. Before collision is the picture shows the ping pong ball float in a container in a regular situation, and the force on ping pong ball have like bound force, gravitational force, and surface tension force. And in experience, the surface tension force always made the ping pong leave the middle of the container. And before collision, the surface tension force and friction will increase the water surface temperature while dropping, and the bound force and gravitational force will disappear while free fall. But the surface tension force still working, so the ball will slowly sinking into water. And while collision, at the moment of collision, the water which around the cup will squeeze the water below and pass the candy to the ball, and cause the water jet to push the ball. So there are so many forces affect the ball velocity, include the pressure difference, which I said the surface tension force has made the ping pong ball sink, and after collisions, the gravitational force will restore, but the ball have displaced too much water, more than the gravity force. So I simplify the whole procedure into an elastic collision like this. Before this model drop, the little m show the ping pong mass, and the capital M show the effective mass of water. Because I think not all of the water will affect the ping pong ball velocity. So I can write down the first equation. Total momentum equals the momentum ping pong and momentum of effective mass of water. And while the green ball here collisions, in ideal situations, it will have the same velocity but different direction up and hit the ping pong ball, and then they will have the two new velocity V1 from and V2 from here. And I can write down the second equation. And find out useful informations. Here I type out these two equations. First we need to remove the V1 to make the equation more simple, and that will become like this. And then in perfectly collisions, D1 velocity V1 will equal the green ball hit the ground velocity in the loop. And after it's positive, we suppose V2 equals V and V1 equals minus V. And substitute to the equation and we can get this. And we would like to make the association with the release height. So we change the V into this. And in this equation, the most important coefficients is the capital M and the little e. Here, the little e here is shown as the restores coefficients from before and after the collision. And we can use our experience data to substitute in the equation and find out the E and M. Here is our experience variable. The parameters we choose to test is release height and water flow. And this is our experience data. We use a camera which have enough distance with the container to decrease the parallax may cause. And then we analyze the videos by tracker. Oh, here I use a gel to supply a number of omega in the container to maintain the position of the ping pong ball. Oh, here's the first one experience. We fixed our water balloon at 100 mole and change the release height. And then we try to put this equation into a decimals to find out the trend in this equation. It have the condition that the M is fixed while the drop height change. The curvature of this line is not very similar to the last patch, but the trend are about similar. And the next improvement, we fix our release height and change the water balloon below. And find out the higher we drop the containers, the faster the ping pong balls launch out. And from last pictures, we have find out the restores coefficient E and type up a new diagram which is associated with the effect mass of water and the water balloon. We can see as the water balloons more and the effective mass of water will they're bigger. And here's the closed function of the line. And in our conclusions, you can see as the release height extends, the ping pong large velocity will increase but slow down after the peak. And as the water balloon increases, the effective mass of water will improve. But to know the launch velocity of the 2 liters, we we use 2 liters of water, we'll find out that here the pickleball mass is much smaller than the effective mass of water. So if the effective mass, the capital M bigger, and the value here will become a state of value, and only depend on the drop height. So we think that the 2 liters of water didn't make the ball bounce faster. Oh, thanks for listening.
Okay, questions from the opponent? Quick question. 2 minutes.
First question is, what is the cup you use?
Oh, it's a plastic
Plastic
cup.
Okay. What is it? What is the size of the cup? I mean, the area that touches the ground.
You said the
area of the bottom of the cup that will hit the ground.
Because I didn't consider that because we all use the same shape of cup.
Okay. And you say you use a tool to help you maintain the ball in the middle position. Can you turn to that page?
Here.
How did it work?
Oh, actually, I made a bump and set up like here, and to make the water in the container spin and in the same way.
Okay, I see that. Thanks. Let's start the discussion.
Excuse me, the mess.
Oh, let's, sorry.
Okay. Okay, fantastic. Yeah, preparation of the opponent. time's up. So we'll move to the next stage.
So the problem, the main focus is the moment and surface tension. They will also affect, and we are going to find the maximum height. Okay, so their pros and cons. Their pros are they use different volume of water to calculate the 2 liters water from zero. And con is you can't transfer the problem into 2 balls because water is a liquid and it's different from the ball. Okay. And their advantage is thanks.
Okay, so especially between the two sides.
So first, you transfer it into 2 balls, right? But if you do so, because water is liquid and you will have surface tension, and the water will also, if the cup is hit the ground, and water also come out, so that big matter and it will change, right? The ping pong ball is being ejected, but some water also.
Yes.
So that M is not a constant.
The governor says actually cannot be in my model. But to close to the reality, so I transfer the capital M to the effective mass to close to the reality.
Can you turn to your previous? You say that when the ball is ejected, the water will go like this, right?
Yeah.
How come? Why does it happen?
I experiment like this. It's like the water here with the condition of the water here down like right, and the water here will have an impact from this water, right, and the force will flow like this because the water cannot go out. So it's from a circle to the middle. Like this.
And in your experiment, your ball is in the middle, right?
Yeah.
What do you think if the ball is not in the middle? What will happen?
In my opinion, the ball will not be. The ball velocity cannot be because the jet here the water jet head will push the ball out. So
So you think the ball will not fly straight?
fly like the height, fly like the ping pong ball here will not as high as here. Okay.
Why not as high as there is? Because that water not push right on the ball. How do you make sure when the cup drop and hit the ground, it is just manual the platform?
Sure.
I mean, when your cup hit the ground, it might not be just right hit on it. It might be like, it might just be like this. How do you make sure it won't hit the ground like this?
So, yeah, this is this will happen in my experience, right? But to decrease the effect on this, so I do more repeat the same experiments more time to lower its effect. And I want to say that another advantage if I spin the water, if a drop like this is, if I not spin the water will like this, right? And as it falls, it will down like this and much cannot be done like this. So the spin water here likes is to stable the water, the containers in it like this.
You say that according to your theory, if you use 2 liters of water, the speed won't be bigger.
Yeah.
But there might be some difference when you use little water or huge water. So I think maybe you can did you do once or twice experience about 2 liters water to prove your opinion?
Actually, the launch velocity of liters of water is I predict from my experience. Yeah.
Okay. So you didn't really did that experiment.
Yes, because the experience is much harder to do.
Okay, I see that. And in your experiment, you let your rotating speed a constant, right? What do you think if you change the rotating speed?
Oh, I have said that. Hold on. While jumping, the ball like will. This is the stable time, and when it stands, the ball will stay because of the surf tension force. And if I give it more spin velocity, right? It will make the ball much lower, and give the ball more the pressure difference to make it launch.
So do you think it will launch higher or lower?
If I much higher. If I spin it, if I increase the spin velocity, the ball will launch higher.
But the ball is being
at the moment of collision, the balance force is restored. And if the ball is more thin, the balance force will much bigger than the gravity.
So if the ball is more lower when we hit the ground, the ball will fly higher.
Yeah.
You say that the volume of water won't affect.
Actually, it affects, but if you use the part of the launch, I have right on the data like this. It's right. That's right. And the amount of water will increase the effectiveness of water. And as this increase, because the m is very little, the little m is very little in pound mass. So the whole I put the layout and you'll see this much larger. The effect of this little m will decrease, and you'll find out that the whole this thing will become constant. Okay.
If your mass of the water is if your mass of the water is being controlled, I mean the mass is the same, but the cup, one is like this and one is like this. The height of the water will be different, and in that case, the volume of the water is the same. But do you think the ball, the height of the ball being it will be the same?
No, I think it's not the same.
But you say that the volume of the water won't affect. It will affect it only because the mass of the water is different. But in this case, the mass of the water is the same, but the height is not the same.
Oh, I got it. This sentence is around like this. Is only for the shape of bottle, like okay, the container. And I think if I change the container like this or this, the coefficients here will change, and the launch velocity will change.
You only use plastic cup to do this experiment. So
Time is up.
okay, thank you.
Opponents summarize the discussion.
We have just discussion that if other thing will affect the ball height, like if the mass of the water is the same, but the height is the height of the water is not the same because the cup is not the same. Well, the ball goes higher or lower, and the reporter's opinion is that the E will change, so it can compare. And I also say that they should do experiment about 2 liter water to prove their thought. Yes. Okay, thanks.
Okay. So questions from the reviewer.
Question for both
Next.
question for both the reporter and the opponent. So what are the factors that will affect how much water is displaced by the ping pong ball?
How much is it how the pressure difference?
What are the ping pong ball will sink into the water and it will displace the water? And what are the factors that will affect the displaced water?
The factor is the surface tension force like this, and if I use another liquid, it will change form. And
Okay, thank you. And what about the opponent?
The question is what will affect the height
The displaced water.
of the displaced water?
Okay, I will go on to the next question. So for the reporter, in your experiment, you have rotated water to form a swirl in the water, right? And will this affect the sinking of the ball in the water?
oh yeah, it will pull the ball down more.
And did you consider that in your field?
Actually, I cannot sure the spin of water will affect the
Okay, thank you. And question for both the reporter and the opponent. Will the material or the radius of the container affect the water jet forming in the water?
yes.
I think it will affect.
And can you expand how will it affect?
The shape and the
Material.
the energy they will transfer more energy to the water.
And what about it?
I think if you use different kind of cup, the energy of the ball might be different, so it will affect.
Okay, time's up. Declaration of the reviewer. Okay.
Honorable judges and fellow competitors, I'm the reviewer from Team Institute. And here's a problem statement. A ping pong ball is placed in a container of water. When the container is dropped, the ping pong ball will get launched to a great height. What maximum height can you reach with up to 2 liters of water? And the main focuses will be how relevant parameters affect, and how does the phenomenon happen. And here's a review of the report. So first about the phenomenon, he mentioned that the surface tension is the main cause to make the ping pong ball sink into the water. And after the collision with the water, the ping pong ball will get launched to a great height. And for the theory part, he considered a collision model between the ball and the water. And he also talked about the sinking will displace water. And for the experiment part, the parameters are water volume and release height. And about the pros and cons of the report. So here's video demonstration and here explanation of the theory. However, in his theory, he did not extend the restitution coefficient between container and ground, which I think will be an important factor. And he also did not explain more about how the water jets will form in the water. And his theory considers the collision between the pole and the water well, however, he still left off some more concise prediction, and he also do not have errors and theory compared. And review for the opposition. He noticed the lack of discussion on the attributes of the container, and noticed the lack of explanation on the experiment setup. He also noticed a lack of explanation on the collision model and how the water volume will affect. However, he didn't notice the lack of consideration of air resistance and didn't discuss the boundary conditions. And here's the discussion. So the opponent asked, how will the water go to a position of the ball and lift it up? And the reporter answered that because, there will be pressure given by the wall of the container. So the water will flow into the middle of the water. And I agree with the reporter. The position of the ball in the water. So the opponent asked how will this affect, and the reporter thinks the launch angle will be different since the water jet will launch the ball to a different angle and the formation will be different, and I would agree with the report. And for our question, I have asked the reporter about how will the swirl in the water affect the ball sinking. And he thinks that the ball will be pulled down more, and I think that this needs to have further discussion. While the reporter didn't have consideration of the air resistance, and the formation of the water jet isn't considered.
Thank you. Concluding remarks from the reporter.
Here is the concluding remark. The bottom area of the cup should be considered, and if the ball isn't in the middle, it will have lower height. With different cups and the same volume of water, the height changes, while the angular velocity of the water will increase, the height increase due to bigger pressure difference. I'm done.
Okay. Questions from the jury. Professor Lee.
The problem of wanting to make a maximum height of the rock. mention the strategy to reach such a goal. The strategy how to reach a maximum height.
If I have the launch velocity of the ball, I can calculate its when it have the maximum height. Maximum.
Your opinion, how to reach the height, maximum height? I have no idea.
Well, I believe that if there is more water and if the release height is higher, the launch height will be higher.
Other questions? Yeah, Professor Chen.
Thanks. Could you show the data of ball jump height versus launch height? No, the previous. Yes. So the y-axis is the height or velocity.
The parameter here is the release height.
Yeah, the y-axis.
Oh, it's the centimeter per second. The launch velocity. I'm sorry. The y here is the launch velocity.
The launch velocity. Could you?
Yes, initial velocity of the ping pong.
Oh, I see. So you didn't record the jump height.
Yeah.
So I would like to ask why this launch velocity have a saturation behavior. Yeah, I would like to ask your opinion why there is a saturation behavior, and also to reviewer and the opponent.
I think it's because of air resistance. And make the down velocity to the retreat.
Maybe opponent.
Could you repeat your question?
My question is why there is a saturation behavior, why the launch velocity does not change with the drop height, and the drop height is high.
Well, I believe that the main cause to lift the ball up is because of the water jet. And the formation of the water jet is restricted to the attributes of the container. So even if the release height increase, if the formation of the water jet cannot be completed, then there won't be a greater launch height.
More questions? No? Okay, so the jury will prepare the score. The scores for the reporter 7, 6, 5, and 4. For the opponent, 6, 3, I'm sorry, yes, 3, 6, 5, 4, and 6. Okay, finally, this goes for the reviewer. 6, 7, 5, 5, and 6. Thank you. I'd just like to make a comment. Okay, so the reporter got 2 questions, right, from the jury. All, for the height of how high the ping pong ball can go, right? But that's the question. Okay, but you didn't really, investigate that phenomenon, right? You talk about when you measure the velocity and other things, but you should really take into account how high the ping pong ball can go. Okay, and that's the question asked by the. Okay, that's it.